Hi, I'm Yolanda.
And I'm Pramugdha. If you've ever used Netflix, YouTube, Amazon, New York Times, you must have seen that these websites predict what you might want to watch or read next, or other products that you may be interested in. Numerous websites these days use programs to determine user responses to options. Such facilities are called recommendation systems. These systems use a number of different technologies which are generally classified into two broad groups. The first is content-based systems and the second is collaborative filtering systems. Our focus today is on collaborative filtering systems, but first let's discuss content-based systems. Amazon uses content-based systems. These systems examine properties of the items recommended. Similarity of items is determined by measuring the similarity in their properties. So, for example, you watch a lot of alien movies on Netflix, then they would recommend a movie classified in the database as having the alien genre, or science fiction, whatever. You must have noticed this before. If you're purchasing a particular book on Amazon, they show a list of other books that people have purchased with the book you're looking at. So how does the system work? Profiles are constructed for each item, which is essentially a record or collections of records representing important characteristics of the item that are easily discovered. For example, for a movie, the profile may include the set of actors, the director, the year in which the movie was made, and the genre. Various other features of movies could be used as well. A lot of mathematical calculations and computer programs later, Amazon, or rather website, presents to you as recommendations. Netflix is one of the most elaborate users of collaborative filtering systems. The goal of Netflix is to predict how a user would rate a movie he or she hasn't seen yet.
They recommend movies with the highest predict rating for their users. This system takes into account the history of star rating across all users and movies. If you just think Netflix as a toolbox, there are inputs and outputs. What is inputs? First of all, the index of users. It can be represented by a U. Then, the movie ID, which can be taken by I, and then there will be, of course, a rating as 1 to 5 stars, and we call it RUI. And the time it happened is TUI, which we are not going to talk in this video. So, we got U and I, and RUI and TUI. We have millions of users and millions of movies. Although no one will watch every single movie, but you can imagine the number of rating. We have billions of rating. The output is obviously the prediction. Then you can compare and evaluate your prediction.
So let's see how we can predict the preference of users. Let's see a simple example. Here is data from 8 movies and 6 users. In real life though, we may have over 100 million data sets. The numbers in the forms show the star ratings by users. The blanks represent the movies users didn't watch and didn't give the star rank to. How do we predict the blanks then? Let's suppose tastes of users are similar. We can then predict the star rating of other users by the statistics we already have. For example, what would we fill in this blank? We can see for this movie, the users who have already ranked the movie give high ratings of 5. So we can predict that the people who haven't watched the movie will like it too. So we can put 5 in the blank. Similarly, if we look at other blanks, we can predict the star ranking with the same method. However, what about controversial movies? For example, movie 7 here has both high and low ratings. We need more data to predict more accurately. The actual prediction can be more complicated though. So how can we test the accuracy of the prediction?
We simply use all RUI and R hat UI we get. Of course, we need to know the difference between the true rate and the predicted rate. It can be overshoot or undershoot. So we need to take the absolute value or we just squared it. And how many do we have? We have C of UI pairs. So divide the square by C. Then we sum up those UI pairs square differences and take the square root of it. Here we recommended this new method, RMSE. R stands for root, M stands for mean, S stands for squared, E stands for error. Our goal is to minimize the difference between predict rating and the actual star rating. So, the ideal value of RMSE should be small. The smaller, the better. Then, we can show how the predictor operates. According to a baseline predictor, in general, we need to build a parameterized model. That is some mathematical representation of the problem you want to solve. The model will go into the circle training phase first. When you have some observation but you also have the ground truth, take the observation and make the prediction and compare with the ground truth, and the difference is something they want to minimize by turning the model parameter, and you then go to the real training, which is the prediction, and take the observation. So, rating training is followed by prediction.
Let's talk about global structure. We use the neighborhood method here. We can compare the similarity between two users and two movies. Here is a simple picture to explain how it works. Suppose we have two movies and two users. We assume it is movie A and B for users 1 and 2. Now we can see for movie A, user 1 gives it 5 stars while user 2 gives it 1 star. And for movie B, user 1 gives it 2 stars while user 2 gives it 5 stars. We can get two vectors from here, namely A and B. The cosine of the angle between them can be calculated. We call this the cosine distance. We can use this method to calculate the relation between movies and users.
Then, when we come to several movies and several users, we get a more complicated situation to compare the similarity between users. We have matrix systems. Let me just provide a simple example. Suppose there are 7 different movies. Let's say Harry Potter 1, 2, 3, Twilight Saga, and Star Wars. A and B and C all watch 3 movies each. So the vector ABC is no longer 2-dimensional, but 7-dimensional. And as we calculate the cosine distance, we just use a formula to calculate, and we can generally judge directly. We can find A and B star rate towards the same movie is closer than A and C.
And that's all. Fun fact, Netflix Prize was an open competition for someone who designed the best collaborative filtering algorithm for Netflix's website. However, they had to cancel the competition 3 years later because of a lawsuit.
Thank you.